Imagine an object so dense that if you dropped a single sugar cube of its material on Earth, it wouldn't just sit there. It would punch through the crust like a bullet through tissue paper, tunnel through the molten core, and oscillate back and forth until it settled at the center of our planet, leaving a trail of planetary destruction in its wake. This isn't science fiction, this is a neutron star. It is a realm where gravity is so absolute, it has crushed atoms out of existence. The iron dead end. Stars are the universe's massive fusion reactors, forging hydrogen into helium, then carbon, and upward through the periodic table. But eventually, they hit a wall. Iron. Fusing iron doesn't produce energy, it consumes it. The moment a massive star's core turns to iron, its outward engine shuts off. In less than a second, gravity, which has been waiting for millions of years, slams the star shut. The core collapses at 70,000 kilometers per second, roughly 25% the speed of light. The resulting shockwave is so violent it disintegrates the rest of the star into the cosmos. This is the Type II supernova. Beyond the atom, the degeneracy limit. What remains is a city-sized sphere of pure neutrons. While normal atoms are 99.99% empty space, a neutron star has no empty left. It is held up by neutron degeneracy pressure, a quantum mechanical no entry sign. According to the Pauli exclusion principle, neutrons cannot occupy the same quantum state. They fight back against gravity with a force so powerful it halts a total collapse into a black hole. To visualize the weight, 1 teaspoon of this star weighs 6 billion tons. That is the equivalent of every human being on Earth packed into the volume of your thumb. Nuclear pasta, the strongest material in the universe. Deep within the crust, pressure forces protons and neutrons to arrange themselves into complex, space-saving structures known as nuclear pasta. First comes the gnocchi phase, small spheres of nucleons. Then the spaghetti phase, where nuclei stretch into miles-wide strings, followed by the lasagna phase, flattened into massive parallel sheets. This pasta is 10 billion times stronger than steel. It is the hardest substance in the known universe, capable of supporting mountains on the star's surface that are only millimeters high but heavier than the Himalayas. Pulsars, the cosmic lighthouse. Born from collapse, these stars spin at dizzying speeds due to the conservation of angular momentum, much like an ice skater pulling in their arms. Some rotate 700 times per second. These are pulsars. They emit beams of electromagnetic radiation that sweep across the vacuum of space with atomic precision. They are the most accurate clocks in existence, losing only 1 second every billion years. NASA is currently developing X-ray navigation to use these pulsars as a deep space GPS for future interstellar travel. Magnetars, magnetic madness. Then there are the outliers, magnetars. They possess the strongest magnetic fields in the known universe, trillions of times stronger than Earth's. In a magnetar's field, chemistry itself breaks down as atoms are stretched into needle-like shapes. If you were to fly within 1,000 kilometers of one, your body would literally dissolve. The magnetic field would strip the electrons from your atoms, turning you into a cloud of plasma in a millisecond. Kilonova, the origin of wealth. When two neutron stars collide, they trigger a kilonova. This is the only environment violent enough to initiate the R process, rapid neutron capture. In the frantic seconds of the collision, free neutrons are forced into atomic nuclei so rapidly they forge heavy elements, gold, platinum, and uranium. Every gram of gold in your jewelry wasn't born in a sun, it was forged in the wreckage of two dead stars colliding billions of years ago. You aren't just wearing luxury, you are wearing the debris of a cosmic car crash. The mass gap, the final boundary. Even these monsters have a limit. If a neutron star accumulates too much mass, exceeding roughly 2.1 to 2.5 times the mass of our Sun, even the claustrophobic neutrons cannot withstand the weight. The star collapses one final time. In this transition, there is no pasta, no light, and no escape. It becomes a black hole. Neutron stars are the final waiting room of the universe before matter vanishes forever into a singularity.